Okay, we're live with Jeremiah Lowin, CEO of Prefect. Welcome to Data Sharks. We've also got
Thanks so
Arkady
much.
Kleyner, and I'm Jared, and we're gonna dive into the world of Prefect and orchestration and what that world is all about. So Jeremiah, this channel, it has all types of people. It has super users, super, technical folks, to people that are completely new, some of them in college. So let's just start with the problem that is trying to be solved by the orchestration tooling, and then let's graduate that into Prefect, and how Prefect looks at this problem, and we'll jazz around that for a little bit.
Sure. First off, Jared, just thanks for having me on. This is a lot of fun. We all have a long relationship to draw on here, so we got a lot to talk about, I think. It's interesting. Our users mirror your audience. We have people who are very new to technical workflows and even coding in general, and we have deep experts who really want to push the limits of what their systems can do. And the problem that we solve is actually common across all of them. We call it the negative engineering problem. And it's this idea that no matter what it is that you're trying to do, one line of code, entire application, there's this enormous amount of defensive work that needs to be done to ensure that it will run as you expect, because nobody writes perfect code. And the fault might be yours. You might leave a bug in your code. The fault might be your neighbors, right? They might do something wrong. And the fault might be that the internet goes down or the computer crashes. It doesn't matter. It doesn't matter what the problem is. Code isn't perfect. Technical processes aren't perfect. And so Prefect is a tool for governing that negative engineering aspect of work. We want to give people the tools and the framework to offload it as much as possible so that they can focus on achieving the business outcome and not worrying about, oh shoot, how do I schedule this? How do I get the logs? How do I make sure it retries, but only after 5 minutes, because that's how long it takes to restart, this infinite series of edge cases. And again, someone who is just getting their toes wet in the, dipping their toes in the pool, they encounter this in a special way. And someone who's been doing this their whole career, they encounter it in a special way as well.
Got it. And it encapsulates a lot of different kinds of processes, right? So like data loading processes all the way to different kind of application scenarios. Like, what are some of the types of processes that you guys take on for orchestration?
It's shocking how far people have pushed the system beyond anything that we expected. I think the bread and butter use case that most people are familiar with is just moving data from A to B. So a classic ETL, right? I have rows in my database that need to end up in my data warehouse, and I need to make sure they get there. And so scheduling that to happen every night at midnight or every hour, or whatever the case may be, and getting reports if it succeeds or fails. That might be the most basic case. But where this starts to get really fun and interesting is when you go beyond that and you get into situations where some of our users are pumping hundreds of thousands or even millions of analytic tasks through our systems. And it's very interesting to see how their perception of the system is different than someone who's running these 3 mission critical ETL tasks every night. So both of them care deeply about the success of the system. But as you get into these analytic workloads with millions of tasks, the failure of any one task may or may not matter in the same way as moving mission critical data to like an archival warehouse. And so our data science users, which is how we sort of characterize these larger graphs, our data science users tend to, more than 10% of the tasks failed, let's just retry the operation. Or only 3 of the million failed, that's completely within bounds, and move forward. And in part, the value add is actually just knowing whether it was 3 tasks or 100,000 tasks that failed. That alone can be a piece of information that, absent a governing system like ours, is very difficult to ask.
So that, just looking, I always try to pull my mind out of what I understand and what I didn't understand at some point. When you talk about these tasks, what do you like when someone hears 100,000 tasks? It's like, what, 100,000 tasks? Like, what does that mean? What is a task for people?
Such a good question. I think one of the most important things that we have really tried to do is not reinvent the world and ask people to sort of subscribe to an entirely different way of thinking. We've tried very hard to make sure that the concepts in our system align with how people talk about their work semantically. Task is a good example of this. A task in our world is exactly what you might think it is. It's a thing you want done. And again, our job, we're the negative engineering tool. So our job is not to tell you what to do, how to do it, what you're allowed to do. Prefect will never say to somebody, oh, sorry, we don't know how to handle that work. Or like, that's not our job. Our job is to take whatever you want and we'll get it done. So a task in our world means if you want to load one row of data and decide if it has a certain value or not, that could be a task. If you want to run and if you want to train an entire machine learning model and deploy it, but that operation is the single sort of unit of work in your world, then that could be a task. We really don't care if it's very, very, very small or very, very big. To us, we're just waiting for our users to tell them, what is it that you want governed? So when we look at these analytic things with hundreds of thousands of tasks, I actually couldn't tell you exactly what it means to our users. Part of our whole, as you guys know, part of our whole thing is we actually have no access to the code or the data, so we don't always know. But it might be that they, excuse me, it might be that they're running a model across 100,000 different things. They're mapping it out and fanning out. It might be that they are actually doing hyperparameter optimization over a grid of 1,000, 100, whatever it might be. The important thing for us is that whatever it is that they're doing at any scale, at any duration, any complexity, our job is just to keep track of it, report on it, make sure that it is in an introspectable or observable state for our users.
So let's talk about some of the problems that happen with that. And this is sort of pre-prefect. Is that it? Yeah, pre-prefect. So pre-prefect, what was the world like pre-prefect in dealing with this type of scenario where we've just got lots of tasks and they all have to happen in a certain sequence or a sequence or have to happen one way or the other? What was the world like that really made something like prefect something that could fix the problem?
I think the best way to answer that is actually to go way back in time and just sort of talk about the evolution of why people even care about some of the features that we're talking about. Because the truth is, a lot of what we do at Prefect, you could look at any specific instance of it and say, well, that's kind of easy. That seems trivial. Oh, you retry code. So does everyone who writes it, try accept.
Yeah.
And what really characterizes this is the emergent complexity of doing this all at scale and in a coordinated way. And so if we go all the way back, forget what was done before Prefect. Let's just say you wanted to run code at 9 a.m. and it's 1983. You literally like run the code. There is no infrastructure. There is no tooling.
Yeah.
And then I think it's 1984. Yeah, well, I think it's 1984 that cron shows up, which if I'm wrong, Wikipedia will tell us, but I'm trying to pinpoint that exact year. And then cron shows up, and cron, some of our listeners are certainly familiar with, and some may not be. Cron is a tool for scheduling things and running them on a single node, right? So I say, great, cron, I want this to run every day at 9 a.m. And now my script is automated. And I say, okay, that's great. And that takes us for a while. And then it turns out that I actually want to do two different things. I want my script to run, and then when and only when it completes, I want a second operation to run. So in the cron world, the only way to do that is to schedule the first one for 9 a.m. and the second one for like 9:30 when I'm sure the first one's completed. But I got a problem now. What if the first one didn't succeed? Yeah. And what if the second one depends on the first? And so we introduced this idea of dependency resolution. And there's this litany of workflow schedulers that show up in the 90s and in the early 2000s that are really premised with this idea of if this, then that. And it's this DAG is the term we use to describe this structured flow of information. And then a few years ago, maybe I guess now coming up on 7 years ago, a tool called Airflow was introduced, Apache Airflow, of which I became a principal author. And Airflow took this idea of DAGs and it moved it from configuration files, YAML files, and some more horrible cases, XML files, and it moved it into Python, which is sort of a beautiful language and the de facto language of data scientists like myself. And all of a sudden, for a data scientist, it was the first time that you had access to this robust dependency resolution and scheduling in a Python familiar environment. But one large but, you had to buy into that Airflow DSL, that Airflow framework, that Airflow way of doing things. And when there was no alternatives and when this was brand new, that was an acceptable cost. But Airflow was not. Airflow was moving that legacy framework, those config files, into the data science realm. And so it brought all of that baggage. And so I, as a data scientist and machine learning researcher, I am used to spinning up hundreds of thousands of tasks, running large scale billion parameter. So that doesn't cut it for me. I don't need a system that measures throughput in tasks per minute. I need a system that measures throughput in milliseconds per task, which I have in my data science tooling. Dask, TensorFlow, PyTorch, those are amazing ecosystems of fast, scalable tools. And when you compare it to sort of what used to be state of the art in the data engineering world, like Airflow, it's like it's like a different era of software. And so we began to work on Prefect to bridge that gap and take some of these workflow orchestrator semantics, like working with failure as a first-class object. As a data scientist, if something fails, as we said earlier, you might just retry it. And so maybe failure isn't like a first-class thing that you need to intercept and work with. But in the data engineering world, it is. And so our first Prefect prototype, we took those stateful semantics, success, failure, retry, whatever, and we slapped them on top of our favorite data science engine, which is Dask. And so we got the speed and scale of Dask, millisecond latency, data transmission, all these things. None of the orchestrators we've mentioned, by the way, could pass data between tasks. That was something that I, as a data scientist, always needed. Because the idea that you would do something and then you do something else, and your orchestrator has no idea how to move data between them as a first class is just mind blowing to me as a data scientist. Like, how do you build a pipeline? So Prefect was supposed to solve what we viewed as these common sense frustrations, and just has taken off in this most fabulous way, and it's amazing to see it grow.
Yeah. So and you talked about, in one of the, I remember Arkady sent me your video, really early video about negative engineering. He sent this over to me, and Arkady's like, "This is what we're talking about. This is what's needed, is this ability to gracefully address situations where it doesn't work out." And so speak to that a little bit in terms of, kind of the ethos around that and how you guys handle, what is that, and then and how it handles jobs, and then go through the expanded version like we talked about in the pre-show.
Yeah, and in fact, let's go into maybe a little more detail than I've really, I think, had a chance to talk about in the past, because there's some interesting and pragmatic things in there that are honestly tied to, like, how do you build a startup? And one of the reasons that this term negative engineering exists is because I needed a way to sum up this concept that is very difficult to describe to people. And I actually tried many different phrases and terms. And the reason it's negative engineering is because negative engineering was the phrase that no matter who I was talking to, no matter their knowledge level or anything, when they heard negative engineering, they would start to nod. It had some resonance, and it was, it was correlated to the quantity of interest, if you know what I mean. And what we're talking about here is why is it so complicated? Well, partially it's complicated because it doesn't seem hard. A thing failed. Great, let's try it again. It doesn't seem hard. But in fact, if you invert the problem, it's not about detecting failure. Often it's actually about detecting the absence of success. Because when the node crashes, there's no, you don't know that. What does that mean to be aware of that? There's no signal that goes out. There's no defense mechanism. The computer crashed. So this notion of detecting the absence of success, which is the much more interesting and rich version of this, is, well, we could talk all day about what it is, and it's fascinating, but it's very hard to talk about with people in a meaningful way unless they've experienced it, unless they've experienced that sort of hollow feeling of, oh my God, I don't know where my code is. I don't know what the state of my system is.
Why I have,
what's going on? So negative engineering became this really effective way of encapsulating that and saying to people, you are an expert in ETL, machine learning, data transfer, whatever it is that you are an expert. You're an expert in that. So go do that. You should go do that. But you spend an awful lot of your time trying to make sure that something ran when it was supposed to, or logging in the next morning to see if the database was updated, or sending emails, or whatever. That is the piece of it that we want to own. That is the piece of it that we want to take off of your plate. That is the negative engineering. You are doing the positive engineering. Now, we were talking just before we started here. Our understanding of that has evolved over time in a very interesting way as the data stack has matured and as we see the variety of use cases that our product is applied to. The term negative engineering has taken on this double meaning. It's not just negative in that it's the opposite of the business objective, the positive engineering. It's negative in that it tends to arise between things in the negative space. So between a data science team and data engineering team, between a database and a data warehouse, between product A and product B. And as the modern data stack emerges and we have these really incredible tools that are almost forming mini stacks within the modern data stack, the number of these negative gaps explodes as well. And part of why I think that's such a hard problem to solve is because there's no natural owner of that gap. If you going back to it's easiest with teams, you have a data science team, you have a data engineering team, you have the model is handed off to go into production. If something fails, the person who may intercept that error is not the domain expert who knows how to necessarily interpret it. And so that it falls into this gap between the teams, into this negative engineering gap. And again, how does Prefect help here? Well, because we gave the data scientist in this example the ability to provide those failure case instructions to define that insurance layer, notifications or retry instructions or whatever the case may be, all of a sudden that credit assignment problem is solved. When there's an error, it doesn't go into this, who the hell do we go find to solve this, to work on this? The instructions have been provided, they're going to be executed as expected, and the problem can be resolved.
Yeah. One of the first things that sort of drew me to Prefect was this concept of negative engineering. I think and we talked about it a little bit at the pre-show, we're all about simplifying complexity. And so I found myself working in Jupyter, working with TensorFlow, building these data science pipelines. But then I had no mechanism that I was used to in the enterprise world to bring it to life, to bring it to something where I can orchestrate. And so I've got Dask, and so I'm left here to build all of that mechanics and monitoring and auditing and a modern, so that's the other big piece of Prefect. It's the modern data stack, its ability to get to data through GraphQL. It's all of those little things that seem trivial or minimal in terms of architecture, they're pretty big. And so, Jared, you're certainly familiar with the Intricity data factory.
Yeah.
And so for us, we needed a conveyor. We needed the orchestration layer to go into that architecture to be able to support. So here we are talking to customers about continuous integration, continuous deployment being applied to data pipelines, data science pipelines, data transformation pipelines. We're taking and migrating from large enterprise tools that had a scheduler built in as part of its ecosystem. But we don't have anything comparable to replace it with, and we live in Python. And so that's the challenge, and that was one of the things that sort of sparked the interest to reach out and say, Jared, we've got to be looking at this because this is different than what Airflow provided.
And just so that for the college folks, what is Dask?
Dask is a fantastic distributed computation platform. I think it's one of the easiest ways that you can sort of gain distributed computing in Python. It's a platform that I've been using really since it was released for this reason, because it's easy to use. It just made it very easy to farm out any function to a cluster of nodes and gain that parallelism. And so it is much more than that, to be clear. It's really an out of core computation framework, but that is when I talk about Dask and a Dask cluster, that is the thing that it's delivered for me in my career.
So as you execute these, we'll just call it workflows, as it goes through, say, Prefect, does Prefect do the retries on stuff as it fails, or does it go straight to like a message queue to say, hey, or is it all of the above?
It is a little of all of the above. I think one of the things that we've tried really hard to do with Prefect and a focus for ours as we evolve the product even further is to separate the instructions for what you want to happen from what actually happens. So if you want something to retry immediately in process and just oh, something happened unexpected, do it again, we can facilitate that. If you want something to retry an hour for now and the process can shut down and we'll spin it back up for you later, we can do that as well. And this, someone's cutting a tree right outside my window. I hope it's not coming through.
You're all right.
Real life.
But what can you do? But this flexibility is our job. So if you can express the instruction in a meaningful way, our job is to communicate that at the time you need it, whether we can detect the failure or whether it's the absence of success, to an execution layer, an execution platform that will actually carry out your instruction. Now, Prefect's a Python library. If you want to write your code in pure Python and have it run in the Prefect process, that's great. Nothing wrong with that. But it was very important to us to always design with these very first-class integrations so that if you love Dask and Dask is your preferred tool for scaling out work, great. We're not trying to reinvent the wheel here. Again, our job is not to replace the positive engineering that our data science customers love. It's to enhance it with this insurance layer, this negative engineering layer.
So I like your idea of sort of being the, filling the gap that exists between the teams, because I think Prefect exactly exemplifies that. Because the challenge a lot of times is that I understand Python, but I don't understand all of these things that are required to sort of bring these components together. And the Prefect library is elegant in the way that you've abstracted the complexity that sort of, as a Python developer, I've got a decorator that I add to my function. And so there are a lot of really elegant things that I think are also important to highlight. That's probably the most important thing that makes Prefect a success, is the ease with which it can be adopted by those who are already doing the positive side of the engineering as well.
Mm-hmm. Mm-hmm.
That is very much our intent, is to meet our users where they are and not invite them, as Airflow has done, as other orchestration platforms do, not invite them to adopt yet another way of working to gain a limited feature set. And a lot of what you're describing, I think you both know our CTO, Chris White, a lot of that is that's his fingerprint on the product. Chris has these really strong beliefs about how to build the correct abstractions in the software such that they match the user expectation. And that's what you're experiencing, is that rubber meeting the road, is that the software just seems to work because it really matches your expectation.
Now, walk us through just the very beginnings of Prefect, like where things really just got started, and those I love startup stories. I love those startup moments, the moments you decide, okay, or you have the idea, the spark of it. Tell us a little bit about that.
It's a very boring story. Prefect was not supposed to exist. I tried to convince the rest of my Airflow PMC colleagues that the platform needed to evolve to handle modern data requirements like the ones that I encountered every day, and I could not. And so I built Prefect just to solve, like I needed a solution for this. This was a real problem I had, and Airflow didn't cut it. So I built Prefect. Or I built this very, very early thing that would become Prefect one day. And it was when a number of companies that I worked with at the time called me saying they were also starting to run into the inability of Airflow to scale to their analytic needs. And do I have any suggestions? And I would say, yeah, I have this little prototype thing, you check it out. And they would come back and say, if this was a product, we would use it. And so that's when I had this light bulb moment, and it got on the phone, and paper sold the product about 50 times. And that's when I decided to build a company. And way back then, it was myself and Chris starting off in this windowless little room. It was an inventory closet of one of our investors that they let us use, and that was the birth of Prefect. And then one of the things that we decided then, and I think it's really, really borne fruit for us, is this commitment to our community and to being very transparent about what it is we're doing and how we're doing it. And also an idea that I think was more controversial 3 years ago than it is today, although it's not common today, to very transparently build a business and an open source product side by side and have them become symbiotic.
How did you do that? Yeah, I'm curious about that. Like, how did you make, how did you split it up what was going to be the business side versus the open source community side?
It's evolved over time, partially because pragmatically open sourcing something is very much a one-way door. And so it's not a decision you can be ambivalent about. It's a decision you need to understand exactly. It's always been very important to have an open source component and product. We're members of this PyData community. We love that ethos. We want to participate in it. And so that puts a constraint on what sort of business you're going to build, because it rules out, in my opinion, having any form of an antagonistic business model where, you like that feature, you can see the source code, but it's you need a license. Like that's a half-featured product that you pay to unlock is not how we want to build software. On the other hand, the other major ethos is to build a full-featured open source product, get people hooked on it, and then monetize the community. I think that's also sort of a horrible antagonistic approach. And so our approach instead was, we're going to build a commercial product that appeals to larger companies and has the sort of things that they really care about. And we're going to build a full featured workflow engine, and it's going to do all the workflow stuff, and they're going to work together. They're going to be symbiotic. And we have always treated the open source product as a business. Even though it has no dollar revenue, it has revenue of a different sort. It has this sort of network effect, social capital revenue. And and so consequently, we've always viewed it in that way. And what that's allowed us to do is it's allowed us to allocate resources to the open source product in a very interesting way. It's allowed us to make commitments to do things. One of the things I like to say is, like, every entrepreneur has read this cliche, like, right, do things that don't scale. Fly out to your first 10 customers, don't do it over the phone, do it with a hand. Everybody can recite that who's starting a business, but that seems like a foreign concept in the open source world, where it's very tempting to sort of sit back and have this weird belief that, we brought a bunch of people together, they'll do the work. It's crazy. We're employees of a company. We're literally sponsored to do this work. We're not going to ask our community to do it or hope that they will. And so we try to do things that don't scale in our open source community. And the number one way that I think we as a company have done that successfully is we made this commitment in the beginning to answer every single question within 15 minutes in our community. And we have done our best to maintain that promise. I think in good faith, we've escalated that SLA to something like an hour. But it's a good faith effort. We really do it. If you're in our Slack, which is growing by about 1,000 people a month, it's kind of crazy to see the growth. You will see this vibrant and active community. And I think that's because we have set a culture of positive and responsive interaction. And so that doesn't scale. And we started rethinking that policy when the community crossed, I think, 400 or 500 people. And here we are. We're over 6,000 now, I think. And
that's amazing. Awesome.
We're still doing our best. It's not easy. And our team has evolved its strategy for how we can deliver that experience to a completely open source, non-commercial collection of users. But I'm proud of the work that we've done there, because it's not hard, because it doesn't scale, and because it's become, in an interesting way, a hallmark of our company.
Right. Well, and it makes a difference on the community side, wouldn't you say, Arkady?
It absolutely does. I think one of the things that was impressive is, I was there in the early days where the SLA was probably 5-minute response. But also the other is the engagement with the community, the education, because when you've got a brand new library and you're trying to get information out, having documentation that's updated almost every single day, it was incredible. It wasn't closed. It was open. We had access to the same documentation that everybody else has, but having that responsiveness was incredible as well. And again, it resonates with the community because this is a problem. This is a problem in the marketplace. I looked at Oozie, I looked at Airflow, I looked at every imaginable, the awesome list. I went through all of the awesome lists to identify all of the solutions that are there. And Prefect certainly struck a chord and continues to do so, because again, if you look at what we're doing around Snowflake, that was an important capability, and the fact that we had the ability to, as engineers, as architects, to control the process. You were not telling us, you gave us an example and said, this is how what we think is necessary, and then we've gone and we've expanded well beyond that.
So
I remember that. And that again is another example of this idea of building the abstractions that match the expectation, because with that example, you can go and figure out how to take it into your own use case, business logic, infrastructure, et cetera, extend it.
So during this journey, right? And it's still a journey that's ongoing. So it's not obviously done. So the question that I have is a lot of entrepreneurs that I've talked with, there's a few sort of milestone moments where they look back and go, yeah, I got that feeling that this was going to be big, and it was right here and here and here. Has that happened yet to you? Is there, or could you feel that there was greatness coming?
I don't actually think that there's been a major event catalyst that has really changed our view of that, with one exception, which is in June of 2019, we got a call from a very, very large technology company saying they loved our open source product and assumed there was a commercial product coming, and they wanted to buy it. And that opened our eyes. We already knew the open source product was good, but that opened our eyes to the fact that the commercial product was interesting to a class of customer at a scale we didn't expect. Frankly, I thought that large companies throw money at this problem and they just solve it for whatever use case they have. And it turns out they do, and then that becomes a very sticky situation, and then they need to undo it for the next use case, and it becomes incredibly expensive, and they're looking for lightweight and flexible tooling. And so that was a moment that really, really, really opened our eyes to this. But I think that other than that, there have been great moments in Prefect's history. Don't get me wrong. A couple of weeks ago, last week, we announced our Series B, which was a huge moment for Prefect.
Awesome. Congratulations!
Thank you. We're growing incredibly fast. We're tripling our team now. It's like the world is on fire. But that we have always tried to grow in a way that reflects our confidence, that isn't a bet on. I come from a risk management background. I really don't like having to be right. That's a very narrow and precise world to live in. And we just went through a rather extraordinary set of circumstances that prove that the world is not at all like you might expect it to be. And so very much the way we operate as a company, the way we've developed our culture internally is very much about embracing the idea that not only do we not have to be right, but we probably are not going to be right. And the faster we can learn from those mistakes, and the more cheaply we can embrace those failures, the quicker we can find the right path to be on. And so maybe as a consequence of that, there actually haven't been so many moments where we've kind of been sitting there like, I really hope this is going to work out. I don't know. I hope this, and then it does, and then everything just changes because strategically we try not to put ourselves in that situation.
Yeah, and that makes sense.
The reduction of cost of failure, is that a result of the product's development? Because you guys have, obviously you're seeing failure. You're living in that negative space. Is that a result of the type of product that you guys are selling?
It's such a good question. I think it's. I don't know. I don't know if that's necessarily the case. It's my training, just me personally. It's my training as a risk manager. I think it manifests in many different ways. I've already mentioned Chris a number of times in this conversation. Chris, coming from an academic background, brings a very similar from a different direction, but a very similar ethos about exploration and iterative and how quickly you can learn. And so I think it's just a very healthy way of doing something new. And one of my beliefs about startups is that you need to be very honest about what it is that you're doing. And the fact that by definition, if you're a startup doing it, it can't be obvious to everyone else. There's something about it that looks weird.
I would extend that. I would say, and this is the things that sort of drive us and why we're still doing the things that we're doing. I think it's important for a startup, but I think it's also unexpected but important for someone who's no longer a startup. So if you are a mature organization, and I've had these conversations with CXOs about what would you do if you were a startup? So you're an established 100-year-old company. How would you behave if you weren't? What would you do differently? And I think there's a lot of this idea of we are set in our ways, our process is this. It's the continuous re-engineering. I remember my training through Edward Deming and sort of how do you go through a continuous re-engineering cycle. But even mature companies, if they could learn a little bit from this culture of reinventing and trying and failure is not bad, all of these things would dramatically impact the bottom line. Because if you start, it's all a recipe to us. It's all, a set of decisions you make that ultimately makes a good product, whatever your product might be.
Yeah, it's like you remember Ken Mullally? I think his name was Ken. I know his last name, but he was the CEO of Ford. And back when they were the other car vendors were asking for a bailout, he said, no, I don't need a bailout. And that's the CEO of who Mullally is. And when they were sitting in a meeting and he had just gotten hired, they had this dashboard and it would show everything was green, like no problems in the company. And this was sort of a self-made dashboard. So it was like an Excel spreadsheet with, little green indicators. And he goes, well, we lost, I don't know how many billion it was, but we lost this many billion last year and nothing's wrong. Nothing's wrong with this company. And we lost this many $1 billion last year. And he says, come on, we can do better than this. So the next meeting, someone put a little red indicator on some kind of delivery date. And he stood up and clapped, this is great visibility. We're so excited. So you realize that the larger a company gets, the more sort of inculcated their processes become, so much so that they're afraid to change it. They're afraid of failure in such a stark way that nobody will say anything, down to the detriment of billions of dollars. So having this ethos, it really means something to be able to have this ethos that, hey, we're going to fail. We expect it, and we're going to gracefully change as a result.
Yeah, we have a name for this concept. Actually, we call it inertial thinking, and we do not allow it at Prefect. And that's a very easy thing to say. Excuse me. It turns out it's a very difficult thing to actually do, because what that really means in practice is it means that doing something is not a good enough justification to continue doing something. Yeah. It might be the right action to take. It might be the right decision. Right. But if new information arrives, it needs to be reevaluated and updated. And if you just introduced that concept into an organization that wasn't sort of culturally oriented around such a thing, it would be an absolute disaster, because you would end up with this broad restatement of everything, this reevaluation of everything. And you might actually end up with what you might consider the correct outcome, which is, shoot, these 7 things we actually should do differently. But the 7 new solutions wouldn't align with any global strategy or thinking. And so actually doing this in a real way, it requires the sort of top down. We have a mission, and we have strategic imperatives, and those have objectives, and those are achievable. And the inertial thinking comes in when we're trying to make decisions against those benchmarks. And we really, this is like a real phrase in our handbook. We do not allow inertial thinking, and it's been very valuable for reminding us that we are a startup. And it helps us also remember that just because we're doing something, if we just continue doing it blindly, then we are in fact holding ourselves to this idea that we are correct, which is such enormous hubris to me. And I know a lot of startups go very far by declaring, no, the rest of the world are idiots, and we know this and nobody else can figure it out. And I hate having to put ourselves in the position where that's a part of our culture, that we're better or smarter. It has nothing to do with that. It has to do with very narrow little insights and putting ourselves into a market for workflow orchestration, which is dominated by a 7-year-old piece of software that nobody seems to really like. Why? Because it's a very hard problem with no real owner. Not because it's just waiting for a white knight to show up who is, more brilliant than the rest, and holding on to that, revaluation, that constant reinterpretation of where we are and why we're doing this is, I think, why we can deliver software that is useful to people who are doing things that I used to do in my career that on the surface are, more actionable, more highly levered, maybe even more interesting,
right?
But depend on this foundational substrate that tools like ours are in a position to deliver.
One interesting thing that comes to mind when you said that was there's a video I released quite a few years ago, and in the very intro we talk about CEOs of startups do tend to be very high in openness, the personality traits of openness, and then CEOs of very large companies tend to be high in orderliness. So, and the idea there is that once an organization has identified the mechanism for generating money, that the processes start to become forced into a frame of efficiency to such an extent that they have to have a tremendously high amount of orderliness in that and lock that process in place to keep it producing money as fast as possible. With the greatest amount of efficiency, so that you could perhaps hire, someone who isn't an engineer and just a wrench turner to maximize the amount of profit for that process. And if there's a book by Clay Christensen, he's actually a Harvard professor, called The Innovator's Dilemma. And it kind of speaks to this problem that happens in organizations that, yes, you're going to milk that process for all the money that you can get out of it until you can't, because what's going to happen is someone is going to out innovate you. And you're so stuck in this process. You're so stuck in this way of doing it that you'll literally milk the money until it literally goes to zero because somebody's going to overtake you.
And we see this in natural resources. We see this everywhere. And so with Intricity, we've tried to distill it into, and so the other part of it is, how do you push these ideals to where the rubber meets the road? So in a services-based business, your team, your extended team, are those people who are doing the work on behalf of Intricity for the benefit of the customers. And so we've always had this idea of simplifying complexity, because that's easy to explain. Simplify it, take complexity out of the process, take complexity out of relationships and everything that you do. And then the other idea is always do the right thing. And so there's almost an overbearing desire on our part to empower the folks that are closest to solving the problems to be the ones that are thinking about, am I doing the right thing for the client? Am I doing the right thing for myself? Am I doing the right thing for Intricity? So you have individuals now who can take the technology world and the knowledge that they have to solve problems, but do it through a lens of, am I doing this? Am I simplifying complexity? Am I doing the right thing? So it's been an interesting journey as far as that goes as well. And since Jared named a couple of books, I'm going to name one. And one of my favorite authors is Patrick Lencioni. And so he's got a couple of really good books. Specifically, we love the one about getting naked. Don't read it on a plane.
Don't read it on a plane yet.
Yeah. And the other one is anti-fragility, because I think the thing that we are all involved in.
That's the Nassim Taleb book.
Nassim Taleb, yeah. Is what do we do with fragility? Fragility in process, fragility in ETL pipelines, ELT pipelines, data science pipelines.
Economies.
Deal with that fragility.
Yeah, and if I were going to throw some books on this, I've already mentioned Creativity Inc.
Yeah.
By Ed Catmull, which is sort of at Prefect is our sort of cultural analog. I think it's the best description of the culture we're trying to build that's available publicly. But then I would also add Shoe Dog is a book that I loved by Phil Knight, story of Nike. And the lesson I took away from that book was that enthusiasm for a mission can overcome kind of anything. And it's one of the most important traits to seek as you build a team. And it's just a really wonderful book, wonderful story. And then a book that I read recently by Ben Horowitz, I believe the title is You Are What You Do, which is about culture, and in particular, something that stuck with me was the idea that communication and trust can be inversely related. And the more trust you have, the less communication you require, and vice versa. And I think that resonates especially in a remote world, where organic opportunities to communicate can be relatively infrequent, or maybe harder to come by without some explicit action on somebody's part. And so in a world where communication is lower, trust is necessarily higher in the balance. And so therefore it actually is, sounds like a strange thing to say maybe, but it's more important to foster that trust within an organization than it was before, even all else equal, simply because the communication can be more difficult.
That's one of the things I've always appreciated. Intricity, strangely enough, about 10 years ago, we adopted the idea that we were not going to prioritize location anymore. So it used to be everybody was in New York City. It was like you had to be like within the tri-state area. Otherwise it was just but that changed. And all of a sudden we were distributed across the United States and
COVID.
Yeah, I guess so. But what I realized is that what mattered in terms of, was someone doing what they were supposed to be doing was really the work product. It really wasn't about, keeping a time clock and, hey, did they punch in this many numbers in, whatever that process was. It really was the were they building success? And was it something that they were bringing? And it sort of changed the dynamic of how work even happens. So Jeremiah, how do people find you, your company? If they're interested in Prefect, what do they need to do?
Very important and excellent question. So
yes.
our website is prefect.io, and our GitHub is github.com/prefecthq. And so our open source code is hosted on GitHub, and anybody can go check it out. Our company, our platform, our documentation are available at prefect.io. And you can find us on LinkedIn and Twitter, of course.
Awesome.
We're everywhere we can be.
Excellent. Well, Jeremiah, thank you so much for doing this with us. And we hope to do it again at some point and hear about Jeremiah or about Prefect's next 10,000 customers to adopt.
I can't wait to hear about it too.
I'm sure.
We'll help a little bit. We'll try to help as much as we can.
Yeah, we'll help.
Well, thank you for being such great partners to us for such a long time. It's a pleasure to join you today.
Our pleasure.
Awesome.
Thanks for coming.
Thanks again. We'll catch you all later.